I'm Dr. Michael Greger, coming to you live from my stationary treadmill, just so I don't make people seasick. Back on the East Coast, my Vancouver move did not last very long. This is a CME-approved webinar, meaning Continuing Medical Education for Doctors and Other Medical Professionals. As you can see, I am proud to declare I have no relevant financial relationships with ineligible companies to disclose. That's the kind of declaration statement that's necessary given the long checkered past of Big Pharma secretly propping up PaidShield to push their products. So now they just non-secretly prop up PaidShields to push their products, but I am not one of them. Okay, if at any time you run into technical difficulties, there are live chat room staff standing by. Let me paste that link into the chat. Boom, there we go. And if they are unable to help you, we have Nutrition Facts staff also standing by. Let me paste that into the chat box as well. This is your donations hard at work supporting the nonprofit nutritionfacts.org. All right, please reserve the Q&A button you see for content questions, as opposed to like technical questions. Today's webinar is 2 hours with a pee break on the hour, but I've reserved lots of time for Q&A at the end, so please feel free to add questions using the Q&A button throughout the webinar, and then the Nutrition Facts team will compile them to be answered at the end. You don't have to worry about taking notes or anything. After the webinar is over, we're not only going to send you a full recording of it, but a free link to download all the videos in high def so you can see the videos in their full resolution glory. Okay, let's do this. Today, we are going to be talking about all things NAD, which stands for nicotinamide adenine. If I can't start pronouncing this now, it's going to be a long webinar. Nicotinamide adenine dinucleotide, which is an essential cofactor for hundreds of enzymes within the body, including a purported anti-aging enzyme. Raising levels to extend the lifespan and rejuvenate health. Raising levels can extend the lifespan and rejuvenate health in a variety of animals. What about in humans? That's what we're going to talk about. The 4 main NAD-boosting supplements on the market are nicotinamide riboside, also known as NR, nicotinamide mononucleotide, also known as NMN, nicotinic acid, and nicotinamide. In this 2-hour webinar, I will cover the pros and cons of each of those, as well as the other 5 NAD-boosting supplements on the market, and discuss 3 ways to naturally boost NAD levels without taking any supplements at all. Let's begin with a video that lays out what exactly NAD is and asks the question, do NAD levels decline with age? There we go. Our understanding of nicotinamide adenine dinucleotide, NAD+, arose from humble beginnings as a factor noted to enhance yeast fermentation in a 1906 paper unassumingly entitled The Alcoholic Ferment of Yeast Juice. Little did they know that waves of NAD-related discoveries would go on to yield a total of 4 Nobel Prizes. NAD+ is now known as an essential molecule for all living organisms, required for the function of about 500 enzymes, including, notably, the extraction of metabolic energy from food. The 21st century has produced yet another scientific renaissance for NAD, with the realization that it was critical for the activity of sirtuins, the guardians of mammalian health span I detail in my book How Not to Age. NAD is one of the most abundant molecules in our body. Once considered relatively stable, it's now known to be in constant state of synthesis, recycling, and breakdown. The entire pool of NAD in some of our tissues is turned over several times a day. To maintain cellular vitality in the face of this turnover, an adequate supply of NAD precursors and sufficiently high enzyme activity synthesizing NAD are critical. The importance of NAD is exemplified by the devastating consequences of a deficiency of NAD precursors like niacin, vitamin B3. The deficiency syndrome, called pellagra, is characterized by the 4 Ds: dermatitis, dementia, diarrhea, and eventually death. Thankfully, since life as we know it couldn't exist without it, NAD and its precursors are found in everything we eat, plant, animal, or fungi. But we need to know how to get at them. The niacin in corn, for instance, is tightly bound up, but it can be released by pre-soaking in alkaline lime water. Maize was exported from Latin America to become a dietary staple without the requisite knowledge about traditional processing techniques, though, and an epidemic of pellagra ensued. An estimated 100,000 Americans died from pellagra in the first few decades of the 20th century, before bread started to be fortified with niacin in 1938. The pitch for NAD boosting as an anti-aging strategy goes as follows. All species, including humans, naturally experience a decline in NAD levels over time, and this decline is in fact one of the major reasons organisms age. By restoring youthful levels, the argument goes, these age-related disorders can be delayed or even reversed. Two leaders in the field, one from Harvard and the other MIT, have said, respectively, that NAD boosters may hold the promise of increasing the body's resilience, not just to one disease, but to many, thereby extending healthy human lifespan, and that sirtuin activation by NAD repletion may be the most actionable item to emerge from aging research. Of course, they have both been involved in multi-million-dollar dietary supplement companies. The first premise, that NAD levels decline with age, has been called into question. For example, this 2022 review, Age-Dependent Decline of NAD, Universal Truth or Confounded Consensus, concluded that despite systemic claims to the contrary, the evidence supporting the premise is very limited. Indeed, the most comprehensive study to date found significant changes in NAD levels in less than half of the tested tissues in old versus young mice. The human data are similarly inconsistent. NAD-boosting supplement shills make claims like, by middle age, our NAD levels have plummeted to half that of our youth. But the cited source only shows a drop in brain levels of about 13% between about the ages 20 to 60. A similar study estimated about an 18% drop from age 25 to 70, both broadly consistent with a 14% drop in spinal tap fluid samples taken from those over age 45, average age 71, compared to those under age 45, average age 34. It's unclear if such modest differences would have any consequences, and a more recent study found no significant differences at all in brain or muscle levels between a young group, average age 21, and an older group, average age 69. A study of skin samples found a greater than 50% drop in young adults compared to the skin of newborns, and a further drop of about 60% from young adults to middle age. However, there did not seem to be a further decline from middle to old age. There was a small study that found the NAD levels in the liver samples of 6 older individuals, average age 66, was about 30% lower than that of 6 younger individuals, average age 39. NAD levels also may be lower in macrophage white blood cells in older individuals, but in the blood more generally, half the studies showed a decline with age, and the other half didn't. By far the largest study, enrolling 10 times more people than the other studies combined, found a slight drop in NAD in the aging bloodstreams of men, but no drop in women. The bottom line is that given the conflicting results from the remarkably few studies on the subjects, it's misleading to say NAD universally decreases with age. Regardless, the proof is in the pudding. What about the second premise, that boosting levels late in life can improve health and longevity? We'll address that question next. OK, so NAD is one of the most abundant molecules in the body, involved in hundreds of different types of reactions, so we have to constantly keep making more of it from the NAD precursors we get in our diet, like niacin, or we die. Now, the big pitch you'll read online about why we should take extra supplements of NAD precursors is that the levels in our body decline with age, but it's actually not clear whether that's even the case. But regardless, if taking more NAD precursors makes us healthier or live longer, who cares what our levels are when we get older, right? If it helps, if we boost them even higher. But can we boost them higher, and does it help? Let's turn to my next video. Can NAD boosters increase lifespan and health span? Let's find out. The effects of NAD boosters on aged rodents have been described in the medical literature as profound, dramatic, remarkable. Treated mice had increased physical activity, improved vision, strengthened bones, while delaying or preventing muscle loss, hearing loss, cognitive decline, and ovarian aging. Benefits to nearly every organ and system have been documented, including improved artery function, brain function, heart function, immune function, kidney function, liver function, and muscle function. For example, a single week of an NAD booster was sufficient to restore key markers of muscle health in a 22-month-old mouse to levels similar to that of a 6-month-old mouse. That's roughly the equivalent of reverting the muscle health of a 70-year-old person back to when they were just 20. NAD boosters can also extend the lifespans of animals, presumed to be due to an elevation of sirtuin activity dependent on NAD. This longevity effect was first demonstrated more than 20 years ago in yeast cells. In overexpression of the genes involved in NAD synthesis extended replicated lifespans by as much as 60%. In the microscopic worm C. elegans, NAD-boosting compounds have been shown to extend lifespans by up to 16%. In mice, one NAD booster was able to extend lifespan by a more modest 5%, but this was accomplished even when supplementation was started late in life, which is unusual for longevity treatments. No wonder people are excited about all manner of NAD-boosting supplements. The big question is, do any of these health span or lifespan effects translate to benefiting humans? There are 4 major NAD-boosting supplements on the market these days: nicotinic acid, Na, also known as niacin; nicotinamide, NAM, also known as niacinamide; nicotinamide riboside, NR; and nicotinamide mononucleotide, NMN. NAD can also be given directly, as well as its hydrogenated form, NADH. There are also hydrogenated forms of NMN and NR, also known as dihydronicotinamide riboside. So there is quite the alphabet soup: Na, NAM, NMN, NR, NAD, NADH, NMNH, and NRH. And the body can also make NAD from scratch from the amino acid tryptophan. Given the critical nature of NAD, it is perhaps unsurprising that the body has so many different pathways utilizing a panoply of precursors. Converting tryptophan to NAD requires 8 steps, whereas Na, NAM, and NR can be turned into NAD in only 2 or 3 steps. NMN is a direct precursor of NAD, but when NMN or NR is taken orally, it appears to just turn into Na or NAM via rapid degradation in the bloodstream, or active conversion in the liver. So why take the more expensive NMN or NR if it's just going to end up as Na or NAM? But in bulk, Na or NAM would just cost pennies a day, versus more like $1 a day for NR or NMN. That would add up to hundreds of dollars a year for NR or NMN, compared to closer to only $5 for a whole year's worth of Na or NAM. But cost aside, what are the risks and benefits of all these NAD boosters? That's exactly what I'll cover next. Holy moly, profound, dramatic, remarkable rejuvenation. Muscles, arteries, brain, heart, liver, kidneys, immune system, a longer life. No wonder there's so much hype over these supplements. But what if you are a human? Do any of these actually work for people? Let's go one by one. Starting with the original niacin, also known as nicotinic acid, or NA. The name nicotinic acid was changed to niacin in the 1940s to avoid any confusion with nicotine. Either name has to be better than the original moniker, though, vitamin PP, for pellagra preventing. In the 1950s, NA became the world's first cholesterol-lowering drug. This led more than 20 trials involving tens of thousands of individuals taking high doses of NA for up to 6 years, resulting in by far the most robust safety data we have on any of the NAD precursors. The most striking benefit was found in the Coronary Drug Project, a trial carried out in the pre-statin drug era of the 1960s and 70s. The 15-year follow-up found that those who had been randomized to years of high-dose NA ended up with a 6.2% drop in absolute mortality. 52% died in the NA group versus 58% in the placebo group. This sparked major clinical trials that, sadly, failed so spectacularly that one was even stopped prematurely. All in all, a Cochrane meta-analysis concluded that no evidence of benefits from niacin therapy was found. One possible explanation for the contrasting results is that the early promising trials used immediate-release niacin, while the newer failed trials used slow-release formulations, also known as extended or sustained release. At high doses, regular niacin commonly causes an intense flushing redness and prickly heat sensation similar to a menopausal hot flash. A slow-release version was developed to reduce this flushing reaction, catapulting it into a billion-dollar blockbuster drug. But it simply doesn't work as well to lower cholesterol. The major clinical trial failures led to the withdrawal of the drug in Europe, and the removal from U.S. clinical guidelines for cardiovascular disease prevention. There still may be a role for niacin preparations in the treatment of heart disease among patients who cannot tolerate statin drugs, but what about use for the general public as an NAD booster? There's a series of rare genetic defects that can lead to a condition called mitochondrial myopathy that's characterized by low NAD levels in the blood and muscles. In 2020, researchers demonstrated that these levels could be repleted with 750 to 1,000 milligrams a day of NA, which led to a significant improvement in muscle strength. This was the first and only study to show improvements in muscle NAD levels and performance with any sort of NAD booster. In a control group of individuals without the genetic defect, blood levels of NAD were raised by NA but not muscle levels, suggesting that NAD levels are already topped off in normal muscles. As you'll see, this is a recurring theme among NAD boosters. We know that large doses of NA can boost NAD levels in human blood, but a corresponding increase in sirtuin activity has yet to be demonstrated. Why not give it a try? Because of the side effects unearthed in the cholesterol-lowering trials. NA raises blood sugars, and may increase your risk of developing diabetes. Based on studies of tens of thousands of people on high-dose NA who were followed for years, one would expect that 1 in 43 people taking NA for 5 years would develop diabetes who otherwise wouldn't have. It's unclear if this risk is only limited to slow-release formulations. The safety buffer, the ratio between the tolerable upper limit and the RDA, is the lowest for NA compared to a half a dozen other common vitamins. However, the upper limit is just based on the flushing reaction, which, although uncomfortable, is considered harmless and tends to dissipate over time. Long-term use can have other adverse consequences, though, including stomach ulcers, vomiting, abdominal pain, diarrhea, and jaundice, a sign of liver toxicity, which is worse with slow-release formulations. There is also a theoretical concern that excessive NA intake may contribute to the development of Parkinson's disease. Due to the unpleasant flushing and risk of more severe side effects, interest has moved towards other NAD enhancers. Okay, the nice thing about niacin is that we have a good handle on its safety profile in large doses, given its historic use as this cholesterol-lowering agent. But the not-so-nice thing is the side effects are not great. Not just the flushing, but the increase in diabetes risk, and a number of other adverse effects. And for what? I mean, it doesn't even seem to work in terms of raising NAD in our tissues, except for those with that rare genetic defect. Moving on then. All right, what about a different form of niacin known as nicotinamide, abbreviated as NAM? Ever since nicotinamide, NAM, was also shown to cure pellagra, both nicotinic acid Na and NAM have been collectively referred to as niacin, or vitamin B3, though they are distinct compounds. For example, NAM is not plagued by the same kind of hot flash reaction. Facial flushing attributed to niacinamide in some older studies were likely due to a less purified form contaminated with residual Na. The relative capacity of Na versus NAM to generate NAD is unclear. Neither has been shown to boost sirtuin activity, but both do extend the lifespan of C. elegans. I couldn't find any longevity trials for Na in rodents. However, NAM was put to the test and failed to prolong the lives of mice. What clinical effects might we expect in people? Previously, I explored the proven anti-aging effects for topical nicotinamide on the skin, and the remarkable ability of oral nicotinamide to help prevent skin cancer. I also noted it failed to prevent type 1 diabetes, despite promising mouse data, though it may help preserve residual function in people newly diagnosed with type 1 diabetes, but apparently not enough to affect blood sugar control. What about its use as an NAD booster? In those with mitochondrial myopathy, Na raised muscle NAD levels and improved mitochondrial and muscle function, but in healthy individuals, muscle NAD levels didn't budge. However, the average age of individuals in the control group was 50. What about in older adults, whose muscle NAD levels might potentially be lower? 4 NAD precursors were tested in older adults, averaging in their 70s: tryptophan, Na, NAM, and NR. All 4 failed to improve muscle strength or function, failed to affect mitochondrial function, and failed to even nudge NAD levels in their muscles. Why not give it a try anyway? Again, side effects. Like Na, high-dose NAM can cause gastrointestinal disturbances and signs of liver toxicity. However, NAM may result in more issues involving methylation. The first step in breaking down excess NAM is to transfer a methyl group to it, forming methylnicotinamide. Unfortunately, methylnicotinamide is neurotoxic and can cross the blood-brain barrier. This may explain why NAM can exacerbate Parkinson's-like symptoms in rats, and why Parkinson's patients have higher levels of the NAM methylating enzyme in their brains, the same with Alzheimer's brains for that matter. Excess NAM may also deplete the body's pool of methyl groups. If you read the epigenetics chapter in my book, How Not to Age, you may remember that DNA methylation is critical for the regulation of gene expression. Epigenetic changes caused by NAM-induced methyl depletion have been blamed as the reason why rats fed megadoses of NAM suffer from fatty livers and swollen kidneys. But that was at a human equivalent dose far exceeding what people might take. Is there any evidence that more modest NAM supplementation might affect methylation in humans? Yes, and even with a single dose as low as 100 milligrams. Methylation also plays a key role in breaking down fight-or-flight hormones like noradrenaline, and neurotransmitters like serotonin and histamine. Within hours of a single 100 milligram dose of NAM, blood levels of all 3 become elevated, suggesting their metabolism was impaired by the shunting of methyl groups to deal with the excess NAM. Also noted was a significant rise in homocysteine, which is a byproduct of methylation reactions and a risk factor for cardiovascular disease and dementia. Another potential problem with NAM is that it's a sirtuin inhibitor. Wait, I thought the whole purpose of taking NAD precursors is to boost sirtuin activity. Sirtuin enzymes use up NAD+ and spit out NAM. This allows the body to recycle the NAM back into NAD for further sirtuin use. But it also means the body can use NAM as part of a negative feedback loop. Like a thermostat in the winter that shuts down the furnace when there's too much heat, the body shuts down NAD use by sirtuins when it detects too much NAM. NAM pills didn't exist when our bodies evolved, so in the wake of a sudden wave of NAM, the body must think its sirtuins are churning out too much and dials them back. Perhaps this explains why NAM fails to prolong the lifespans of mice. When the sirtuin-suppressing effects of NAM were first reported 20 years ago, the researchers cautioned that this could potentially lead to deleterious consequences of long-term nicotinamide therapy in humans. Okay, so nicotinamide can be used topically to improve wrinkles. I give a DIY recipe for a cream you can make on the cheap in my book, How Not to Age. You can get it from your local public library. And taken orally, it has been proven to help prevent skin cancer among high-risk individuals, but like NA, appears to flop as an NAD booster. NAD precursors that appear to increase NAD levels in organ tissues in rodents fail to do the same thing in people. Our body just seems too smart to allow levels to be so fickle. And so if we take NAM, the body just has to get rid of the excess, and it does so by sucking up our methylation capacity, interfering with our normal metabolism of hormones and neurotransmitters, and producing a neurotoxic compound in the process. Okay, and it can actually have the opposite of the intended effect by suppressing the purported anti-aging sirtuin enzymes as part of a negative feedback loop. Okay, so what about one of the fancier supposed NAD-boosting supplements, NR, or nicotinamide riboside? Let's find out. NR and NMN seem to be more promising NAD precursors than NA or NAM, since they don't cause flushing, nor do they directly inhibit sirtuins. In mice, NR and NMN both raised liver NAD levels, but of the two, only NR significantly raised NAD in the muscles. Also, NR is so far the only NAD booster shown to prolong the lifespan of mice. There have been at least 10 clinical trials of NR, most showing it can boost human blood levels of NAD by up to 168%. Note, though, that most doses used exceeded 300 milligrams, which is the daily dose approved as safe by the U.S. Food and Drug Administration and the European Food Safety Authority. At the approved dose, blood NAD is boosted more on the order of 50 to 60%, but no dose was found to affect NAD levels in human muscle compared to placebo. The greater preponderance of human bioavailability and safety data for NR compared to NMN has led some to proclaim NR as the preferred NAD precursor, and by some, I mean employees of a chemical company that produces NR for supplements. The question, after all these human NR trials, is, have any of them shown clinical benefit? Sadly, no. Let's go through the alphabet. After accounting for multiple testing, randomized, double-blind, placebo-controlled trials of NR in middle-aged or older adults failed to find any significant benefit over placebo for artery stiffness or artery function, BAT activation, blood pressure, blood sugar control, body weight, cardiac energy or ejection fraction, fat burning, fatty liver, exercise capacity, fatigue, insulin sensitivity, metabolic flexibility, metabolic health, metabolic rate, mitochondrial function or biogenesis, muscle blood flow, upper or lower body muscle strength, pancreatic function or the release of metabolic hormones, the treatment of Parkinson's disease symptoms, or physical performance. NR hawking companies claim NR is anti-inflammatory, but in their own study, only 3 out of 10 markers of inflammation were affected compared to placebo, and a subsequent independent study using the same dose for twice as long found 0 of 12 markers affected. Remarkably, the opposite was found for many of these outcomes in rats and mice. In rodents, NR does raise NAD levels in muscles, improving insulin sensitivity and mitochondrial biogenesis, and on down much of the list. Why does NR work in rodents, but appeared almost entirely flop in people. Some have suggested inadequate dosing. The typical dose used in mouse studies was about twice that used in many human studies, but a double dose has been tried in people to no avail. Another possibility is sirtuin inhibition by NAM, the main degradation product of NR. In fact, based on mouse studies, NR may metabolize in the gut into NAM or NA before it even makes it into the bloodstream. Either way, unlike in mice, NR can't seem to elevate NAD in human muscle, so no wonder there's no alteration of human sirtuin activity. Maybe that explains the disparate results? In fact, the key NAD synthesizing enzyme in human muscle biopsies was actually suppressed by NR supplementation. That doesn't happen in mice, but it does in people. Presumably, this downregulation is an adaptive response to the unnaturally large flood of NR coming into the system. So what happens when you stop taking the supplement? How quickly does your enzyme activity bounce back? In mice, not only may their microbiome affect NR, but the NR may affect their microbiome too. Some of the benefits of NR can then be transferred between mice via fecal transplants. So, at least in mice, some of the benefits of NR may be due to modulating the mouse microbiome. The distinct differences between the gut flora of humans and rodents may offer another explanation why NR works in them, but not us. Unlike NAM, supplementation with NR did not increase homocysteine levels, but one study of a combination of NR plus a resveratrol analog called pterostilbene raised LDL cholesterol high enough to kill as many as 1 in 40 long-term users. However, this effect is presumed to be due to the pterostilbene, as NR alone has not been shown to raise LDL, whereas pterostilbene has. One study did find that NR seems to cause a small reduction in hematocrit, hemoglobin, and platelet count in people within a week of starting it. This shift towards a more anemic state was suggested to account for impaired exercise performance seen in rats given NR. However, the 35% drop in performance did not reach statistical significance. NR did cause a significant increase in systemic oxidative stress, however, and another rodent study found a worsening of inflammation and deterioration of metabolic health. But if positive effects in rodents don't translate to people, perhaps we shouldn't expect the negative ones will either. Regulatory authorities from Australia, Canada, Europe, and the United States have all authorized NR as safe, at least up to 300 milligrams a day, or 230 in pregnant and lactating women, but the lack of demonstrable clinical benefit would seem to preclude NR supplementation. OK, so NR is the only NAD supplement that has been shown to increase lifespan in mammals. But it can increase the levels of NAD in the tissues of mice, but fails to do so in people. This may be because in humans, taking NR downregulates our own NAD-making enzyme in the body. Again, the human body appears too smart to allow the blunt incursion of NAD precursors to actually affect NAD levels in our tissues. No wonder it fails across the board to apparently do anything beneficial in humans after it's been tried over and over and over. But at least it only appears to be a waste of money, as low doses have been determined to be safe. What about the other fancy NAD supplement, NMN, which stands for nicotinamide mononucleotide? Let us see. Both NR and NMN have been shown to have beneficial effects in rodents, though they haven't been tested side by side. Both precursors raise blood levels of NAD in people, but similarly haven't been pitted head-to-head against one another. One potential advantage of NMN over NR is that it may be more stable in the bloodstream. In mouse blood, at least, within an hour, most NR is converted into NAM, whereas NMN levels remain steady. You could also argue that NMN is better because it's a direct precursor of NAD, whereas NR first has to be converted to NMN. So we might as well just take NMN in the first place. Ironically, the exact opposite argument can also be made based on the inability of NMN to pass through cell membranes. Structurally, NMN is just NR with a phosphate group attached to it. The phosphate charge prevents NMN from passing in and out of cells. So to get inside a cell, NMN first has to be converted into NR. Then once inside, the NR can turn back into NMN and make NAD. So if NMN first has to be converted into NR for cell entry, the argument goes, maybe you might as well take NR to begin with, because there's no NMN transporter. Or is there? An NMN transporter was recently described, at least in mouse intestines, so maybe NMN is able to skip the NR step and pass directly into cells to make NAD after all. However, the evidence such an NMN transporter exists remains controversial. NMN boasts a long list of rodent health span benefits, but, unlike NR, has yet to demonstrate an extension of mammalian lifespan. What about in people? There have just been a few human NMN studies published to date. One small study of healthy middle-aged men found that various single doses had no apparent effect on any of the measured variables, including retinal eye function, sleep quality, heart rate, blood pressure, oxygenation, or body temperature. A 12-week study of daily NMN supplementation in middle-aged men and women similarly found no significant effects on any outcome, including lean mass, muscle mass, body fat, blood sugars, cholesterol, or insulin sensitivity. NMN did boost blood NAD levels, though they peaked after the first month and then trended down for months 2 and 3, so there may have been an adaptive drop in NAD synthesis, as was suspected with NR. Like NR, NMN also fails to raise NAD levels in muscle tissue. One study, evocatively entitled Nicotinamide Mononucleotide Supplementation Enhances Aerobic Capacity in Amateur Runners, tested 3 different doses of NMN versus placebo for 6 weeks among young and middle-aged recreational runners. Aerobic capacity was increased at one ventilatory threshold, but not the other. No overall benefit for aerobic capacity or peak power or any of the other 10 measures of cardiopulmonary function was found. If you measure enough things, statistical outliers, both positive and negative ones, can just pop up as flukes. For example, the researchers noted significant improvement in the single-leg stance test, but the NMN had no significant effect on any of the other physical function tests. Upon closer inspection, the apparent single-leg balance benefit was only found in the middle-dose group compared to the high-dose group, because the high-dose group ended up doing slightly worse compared to baseline. No significant effects were found for any of the doses compared to placebo. A similar issue can be found in a 12-week study of NMN supplementation in older adults. The NMN company-funded authors conclude that NMN improved lower limb function and reduced drowsiness in older adults, but it failed to significantly affect 16 additional measures, including other tests of lower limb function and fatigue. There are so few NMN studies that this kind of shotgun approach is understandable, casting the widest possible net for effects to be further tested, but on their own cannot be presented as convincing proof of efficacy. All the above NMN studies were on healthy individuals. What about testing NMN on those who are already metabolically compromised? Overweight or obese postmenopausal women with prediabetes were randomized to NMN or placebo for 10 weeks. NMN didn't seem to affect body weight or composition, liver fat, blood pressure, or a dozen other metabolic variables, but it did improve muscle insulin sensitivity, though not enough to affect insulin levels or short or long-term blood sugar control. This may be because insulin sensitivity in the liver and body fat remained unchanged. NMN also appeared to have no effect on mitochondrial function, or muscle strength, fatigability, or recovery. In terms of safety, NMN shills speak of it as being naturally found in fruits and vegetables, but even the most concentrated sources, edamame, avocado, and broccoli, have over 100 times less per serving than the typical NMN supplement dose. The same could be said for NR in milk, human or otherwise. There are safety evaluations for NMN on rats and dogs, but unlike NR, supplemental doses of NMN have not yet been shown safe for human consumption. There are rodent studies showing that NMN may have negative metabolic consequences compared to placebo, but the most serious concern is nerve degeneration. The accumulation of NMN in nerve cells is toxic. Since NR is converted into NMN, this is a major concern for NR supplementation as well. The type of nerve damage, axon degeneration, is a major contributor to a variety of neurodegenerative disorders. Blocking an NMN synthesizing enzyme appeared to help damaged neurons in vitro, protection that's abolished by adding NMN back. And adding an enzyme that chews up NMN was also found to be protective, further supporting a theory of degenerative effects of accumulating NMN. However, clinical effects remain theoretical, as these adverse effects have only been demonstrated in fish, mice, and petri dishes. Of course, NMN supplements may not even have NMN in the first place. Chromadex, which sells the rival supplement True Niagen, a form of NR, claims to have tested the 22 NMN brands with the highest market share on Amazon, and found that most had virtually no NMN at all. Ironically, many of the apparently fake NMN products displayed quote-unquote certificates of analysis and carried hundreds or thousands of positive reviews. Evidently, only 3 out of 22 were found to contain as much NMN as advertised on their label. Of course, Chromadex isn't above being shady itself. It's been accused of making hyped false claims for True Niagen by both the FDA and the Better Business Bureau. In short, NR has been demonstrated to be relatively safe, but not effective, and neither safety nor efficacy has been established for NMN. OK, so NR may just be a waste of money, safe but not effective, and NMN appears similarly useless and may not even be safe, given the nerve toxicity noted in rodents. But if the positive effects of NMN don't translate into people, then maybe the adverse effects don't either. Well, this is all so disappointing. OK, but what about the other 4 lesser-known purported NAD boosters? That's what the next video is on. Taking niacin, also known as nicotinic acid, would be about 50 times more efficient than taking the amino acid tryptophan to boost NAD, because only about 2% of tryptophan is converted into niacin. Also, tryptophan didn't work to improve mitochondrial or muscle function in physically compromised older adults, even when combined with niacin or nicotinamide. And side effects of taking tryptophan include belching and gas, blurred vision, diarrhea, dizziness, drowsiness, dry mouth, headache, heartburn, and potentially a life-threatening condition known as eosinophilia myalgia syndrome, or EMS. There was an epidemic of EMS tied to tryptophan supplements from a single supplier back in 1989 that led to their removal from the market for about 15 years. Some sort of contaminant was suspected, but the cause remains a mystery. To this day, tryptophan supplements continue to be tainted with impurities, with at least one case of EMS reported decades after the initial epidemic. A case of EMS tied to a bizarre weight loss diet involving hundreds of cups of cashews, a rich source of tryptophan, suggests the syndrome can be caused by excess tryptophan directly. If anything, tryptophan restriction may be beneficial. Nearly 50 years ago, it was demonstrated that restricting dietary tryptophan reduced cancer rates and increased the lifespans of rats and subsequently mice. Vegetarians and vegans both appear to have significantly lower intakes of tryptophan, but only in vegans does this translate to lower tryptophan blood levels, though presumably not if they were to take tryptophan supplements. What about taking NAD directly? This isn't practical because of instability and poor bioavailability. NAD is vulnerable to heat, pH, light, oxygen, requiring dark desiccant storage at ideally 20 degrees below freezing. NAD can be given intravenously, a practice started in the 1950s as an underground treatment for alcoholism, but when taken orally, NAD may be broken down in the alkaline environment of the small intestine, and NADH, the so-called reduced form of NAD, is broken down in the acidic conditions of the stomach. In organic chemistry, the gain of a hydrogen atom is said to quote-unquote reduce the molecule, so NADH is the reduced form of NAD. Enteric forms of NAD could potentially survive the digestive tract, but with the exception of neurons, NAD can't cross into mammalian cells. This is why NAD precursor supplements like NMN and NR were developed. Also, there's evidently unpublished data showing that straight NAD can cause severe hyperglycemia in mice. Has it been tested in people? NAD-boosting supplements had been found to improve the learning and memory of rodent models of Alzheimer's disease in the lab. In 1995, case reports of apparent benefit of NADH for Alzheimer's disease were published. By the next year, an open-label pilot study was published, suggesting it had a protective effect, but without a placebo control group, the only conclusion that could be drawn was to study it further, especially since a similar study with the same dose over approximately the same period found no evidence of any cognitive effects. There have been 2 randomized, double-blind, placebo-controlled trials of NAD precursors for Alzheimer's. One found no benefit for memory, attention, or clinician ratings of dementia severity, but did maybe find less of a drop in one dementia rating scale after 6 months of 10 mg a day of NADH. The other, a 6-month study of nicotinamide, failed to find any clinical effects. What about trying NMNH and NRH, the reduced forms of NMN and NR? They both appear to boost NAD higher than their non-reduced counterparts. In vitro, NMNH can raise NAD levels up to 10 times higher than NMN, and NRH, also known as dihydronicotinamide riboside, is up to about 50 times more potent than NR. There are concerns about stability of NRH outside the body, since it's sensitive to oxygen and moisture, but within the body, NRH may be more stable, not rapidly devolving into nicotinamide like NR does, at least in mouse blood. However, unlike NR, NRH does not appear to be able to significantly increase levels in mouse muscles. NRH is said to have a spectacular potency for increasing NAD levels, perhaps the most potent precursor discovered to date. This may not necessarily be a good thing. The extreme boost afforded by NRH had detrimental consequences in human liver cells in vitro, resulting from an excessive accumulation of free radicals. In addition to oxidation, NRH was also found to promote inflammation. Pro-inflammatory effects were noted for NRH on human immune cells in vitro, but not for NMN, NAM, or NR. Because it appears that NMNH is converted to NRH to enter cells, these potentially deleterious effects may be shared by NMNH as well, though this is yet to be tested. OK, first on the list, tryptophan. Risky, since tied to a rare but mysterious life-threatening disorder. Doesn't seem to do anything, and if anything, getting less tryptophan in one's diet may be better for increasing lifespan and lowering cancer rates, at least in rodents. In terms of NAD, or its reduced form NADH, you really can't take them orally because they're so unstable and can't get into our cells anyway. NRH is also unstable, doesn't even raise NAD levels in mouse muscles, and causes pro-inflammatory and pro-oxidant effects in human cells in a petri dish. Since NMNH is just turned into NRH, it presumably has the same downsides and lack of efficacy. If you are still excuse me, if you are still not convinced that the promotion of these NAD supplements are scams or worse, here's a video of other risks inherent to some of these supplements. Most of the reported side effects for NAD precursors like NAM, NR, and NMN are relatively rare and minor, for example, diarrhea, nausea, rashes, hot flashes, and leg cramps. Both NR and NMN raise NAM levels, so may share in the same concerns regarding sirtuin inhibition, methyl depletion, and potential adverse effects of NAM breakdown products. Another theoretical concern of NAD boosting is the exacerbation of infections by a group of bacteria called Haemophilus, from the Greek meaning blood-loving, though can also cause infections of the lung, brain, throat, flesh, and joints. Haemophilus bacteria lack the ability to make NAD, so rely on host levels, raising the possibility that higher blood levels might worsen the disease course of infected individuals. Ironically, elevated NAD levels may also fuel immune system overreaction in cases of autoimmune and inflammatory disease. When fully activated, the immune system is voracious. The immune reaction to a blood infection or extensive burns can burn 4,000 calories a day, approximating military training in the Arctic. Since NAD is used by cells to produce energy, it's no surprise that we find the primary NAD synthesizing enzyme strongly upregulated in tissues that are actively inflamed. For example, the enzyme NAMPT is elevated in colonoscopy biopsies taken from inflamed areas in patients with inflammatory bowel disease, and higher levels are correlated with greater disease severity. So, for those suffering from chronic autoimmune diseases such as rheumatoid arthritis, NAD boosting could potentially have a profound negative impact. This explains why tamping down NAD with NAMPT inhibitors has been shown to ameliorate colitis and arthritis in mice, but this is yet to be tested in people. Such NAD-depleting drugs have, however, been used in cancer patients. Malignancy is another heavily energy-consuming process. NAD may therefore have a tumor-promoting effect by promoting cancer cell growth and spread. For example, NAMPT, the NAD-forming enzyme, is highly expressed in cancer's brain tumors and correlates with decreased patient survival. This has led to attempts to use NAD-depleting therapies to try to starve cancer progression, but this approach is confounded by rapid onset injury to another energy-intensive tissue, the retina, risking blindness. Giving NMN to mice with pancreatic cancer accelerates the progression of the cancer, thought due to the aggravation of inflammation. The researchers conclude that consumers of NAD supplements must balance the advantageous anti-aging effects with the potential detrimental pro-tumorigenic side effects. Perhaps this explains why the best NAD boosters have ever been able to do is increase mice lifespan by 5%. On the other hand, as you'll remember, NAM successfully prevented human skin cancers, and has been found to reduce the incidence of a variety of carcinogen-induced tumors in rodents. The disparate results may in part be due to the disparate impact sirtuin activation may have on different cancers. Sirtuin activity can be overexpressed in some cancers, like thyroid carcinomas and lung metastasis, but reduced in others, like brain, bladder, prostate, and ovarian tumors. The bottom line is that particular caution should be used for NAD-boosting supplements by those with cancer, or a personal or strong family history of cancer, and perhaps also by those with inflammatory disorders and certain active infections. OK, if you remember from the NAM video, I know there's lots of crazy acronyms. It can cause methyl depletion, suppress sirtuins, the opposite of what we want, and be toxic to nerves. And look, since NR and NMN are converted into NAM in the body, we may be facing the exact same effects. Other theoretical risks of all the purported NAD boosters, and I call them purported because they don't actually raise tissue levels in normal humans, just blood levels. Well, the increase in blood levels could make certain types of infections worse and exacerbate inflammation, and maybe even cancer, right? You don't see that on all the sites trying to hawk you these expensive supplements. Anyway, let me close out the supplement section by answering the question, which NAD booster is best? And as you can probably already guess by now, the answer is none of them. Oh, I was just sharing. I'm sorry. Let's share again. Stop. Okay, share again. Sorry. So which NAD boosting supplement is best? There's no clear standout, as hardly any of the preclinical effects found in the lab have translated into evidence of human clinical benefit. Perhaps this failure is to be expected, given the complexity of NAD physiology, with its juggling of multiple precursors, production pathways, and recycling routes. The bottom line is that it's just too early to say if NAD booster supplementation will ever live up to even a fraction of the hype. Many more, larger, and longer-term studies are necessary to establish safety and efficacy. The problem is that because Na, NAM, NR, and NMN are all natural products, they can't be patented, so the money for well-designed clinical trials is not as available. The reason there have been comparatively more trials done on NR than NMN is that patents were originally issued for NR before being invalidated as unpatentable. Perhaps blindly overloading the system with NAD precursors is not the best way to go about NAD restoration. The body seems too smart to allow such blunt incursion to affect tissue levels. Maybe these supplements are just profit-making distractions from more natural approaches. Broadly, there are three main ways to increase NAD+ levels. Increasing the supply of NAD precursors is just the first. The other two are having the body make more by activating NAD synthesizing enzymes, or have the body use less via an inhibition of excess NAD degradation. The primary determinant of NAD synthesis is the enzyme NAMPT. An abundance of NAMPT tends to decrease with age in human muscle, dropping steadily by about 40% between the ages of 20 and 80. In our liver, it drops by half. However, age-related diseases such as atherosclerosis, cancer, diabetes, and rheumatoid arthritis have been found to exacerbate NAMPT decline, raising a chicken-or-the-egg question. That's where interventional trials come in. Similar NAMPT declines have been noted in aging rats and mice. Does boosting NAMPT help? Increasing NAMPT, or its species equivalent, increases the lifespans of yeast, fruit flies, and rodents. An NAMPT boost also increases aerobic capacity and exercise endurance in mice, in addition to helping them live longer. Enhanced expression of NAMPT increases the NAD levels in the muscles in mice comparable to feeding them dietary NAD precursors. But if you remember, NAD precursors don't seem to be able to affect NAD muscle levels in most people. In fact, such supplements can actually suppress NAMPT while boosting that methylating enzyme to rid the body of the excess. In addition to methyl depletion, chronic administration of these supplements could potentially leave people worse off should they ever stop them. There is, however, a way to naturally boost NAMPT and NAD levels in humans without any supplements: exercise. Athletes have about twice the NAMPT expression in their musculature compared to sedentary individuals. To prove cause and effect, sedentary men and women started a stationary bike exercise protocol, and within 3 weeks, NAMPT levels increased by 127%. Resistance training can also increase NAMPT, and this can also translate into a 127% increase in muscle NAD levels and a rise in sirtuin activity. In other words, exercise can do what NAD-boosting supplements can't. OK, so blindly overloading the system with NAD precursors may not be the best way to go about raising NAD. The body seems too smart to allow such a blunt incursion to affect tissue levels. These supplements may just be profit-making distractions for more natural approaches. What natural approaches? Getting your body to make more of it, or to use less of it. OK, how can we naturally get our body to make more? We can boost the enzyme that makes it, and we can do that with exercise. Exercise can do what no NAD supplement has ever been shown to do in normal people: raise NAD levels in tissues. But unfortunately, you just can't fit exercise in a pill, otherwise, boy, would they charge lots of money for it. OK, what about the other natural way to boost tissue levels? Preventing the overuse of NAD. In other words, NAD conservation. The final video of the series, called The Third Way to Boost NAD. However, it just turned 3 o'clock here on the East Coast, and so every hour during our webinars, take a 5-minute break. Anybody needs to do anything, I'll be back in 5 minutes to show the final video, and then we will move on from there. So 5 minutes on the clock, and we'll talk to people very soon. Okay, so let us find out how to preserve our NAD. There are 3 NAD boosting strategies. Increasing the supply of NAD precursors is just one way. The other 2 are having the body make more by activating NAD synthesizing enzymes, or have the body use less by, for example, conserving it by using less. Besides sirtuins, the major consumers of NAD are PARP1 and CD38. PARP1 is an enzyme that uses NAD to repair DNA. The more oxidative DNA damage, the more single and double-stranded DNA breaks. The more enzymes like PARP1 need to be activated to come to the rescue. This uses up a lot of NAD. As DNA damage accumulates with age, the rising need for repair enzymes like PARP1 causes a major drain on NAD levels. Exposing cells in vitro to DNA-damaging agents such as gamma radiation or genotoxic chemicals can cause an 80 to 90% drop in NAD levels within a matter of minutes. This has led to the search for PARP1 blockers to preserve NAD levels, but rather than blocking DNA repair, why not work to prevent so much damage in the first place? For example, the severe oxidative stress of a high-fat diet can lead to PARP1 activation and NAD depletion in mice, but NAD levels can be dramatically restored by feeding them purple sweet potato color, the natural anthocyanin and pigments found in purple sweet potatoes. Or, of course, you can just not feed them a high-fat diet. DNA repair is a good thing. PARP1 may be one of the reasons NAD-boosting interventions can improve health spans and lifespans in laboratory animals. Greater PARP activity strongly correlates with longer lifespan across about a dozen mammalian species, and the PARP activity of human centenarians averages 60% higher than younger controls. However, persistent activation can lead to NAD depletion, and overactivation can lead to cell death, so we should try to keep oxidative stress to a minimum. CD38 is another major guzzler of NAD. It's an enzyme that uses NAD, found concentrated on the surfaces of immune cells, and robustly induced in the context of inflammation. The rise of CD38 activity with age has been blamed on persistent inflammaging activation, the rise in systemic low-grade inflammation in our bodies when we get older, which may be a major culprit for falling NAD levels. For example, blocking CD38 has been found to raise NAD levels in old mice comparable to that of younger mice. So, oxidation and inflammation can lead to a drop in NAD levels due to the excess activation of the NAD-consuming enzymes. This may explain why protective sirtuin activity is reduced in obesity, a condition characterized by oxidative stress and inflammation. A study of identical twin pairs, in which one on average was obese and the other not, found significantly less sirtuin expression in the obese twin despite having the same genetics, and randomized people to a 6-month trial of 25% calorie restriction, and you can show a boost in sirtuin expression along with a decrease in DNA damage. Protein restriction may have a similar effect, since men and women with higher protein intake tend to have lower levels of NAD in their blood, thought to be due to the oxidative stress induced by protein breakdown byproducts. If oxidation and inflammation are responsible for a drop in NAD levels, then what about the antioxidant and anti-inflammatory phytonutrients in healthy plant foods? After screening more than 14,000 compounds, almost all flavonoids were found to be effective in a test for CD38 inhibition. The 2 most effective were cyanidin, found in red cabbage and blackberries, and quercetagetin, found in marigold flower tea. Another study found the 3 most potent compounds were luteolin, curomanin, and luteolinidin. Luteolin is found concentrated in oregano, radicchio, and chrysanthemum tea. Curomanin is found in blackberries, purple corn, and hibiscus tea. Corn tortillas are surprisingly easy to make, so why not choose blue or purple masa to make them even healthier? Luteolinidin, found to increase the NAD in the hearts of rats, can be found in red sorghum, one of the components of my prebiotic Brol mix when I can find it. The flavonoid apigenin is a well-established CD38 inhibitor. When given to mice, apigenin boosts NAD levels by about 50%, which is what people would get taking the maximum tolerable daily dose of NR. The best sources are parsley and chamomile tea. A wide range of flavonoids found in green tea, turmeric, and fruits and vegetables have also been found to prevent NAD depletion in human cells in vitro at levels found in the blood after consumption. How much do you have to eat, though? Proanthocyanidins have been found to lower PARP1 and CD38 expression in rats. NAD and sirtuin activity was significantly boosted at the human equivalent dose of about 280 milligrams a day. How much is that? That's the amount of proanthocyanidins found in a single apple. You could also reach that dose eating 2 plums, a half a cup of wild blueberries, a little over a teaspoon of cinnamon, or a little over a tablespoon, like 4 teaspoons, of cocoa powder. Quercetin is another suppressor of PARP1 and CD38, shown to increase sirtuin activity in mice. The concentration necessary to lower PARP1 in vitro can be achieved by taking a quercetin supplement, but typical supplement manufacturers' recommended doses are up to 100 times the average daily dietary intake. Thankfully, food works too. Researchers fried up 1½ yellow onions and raised quercetin blood levels to about 75% there, and so 2 onions might do it. There's no long-term safety data on high-dose flavonoid supplementation, so public health researchers suggest caution should be exercised in ingesting them at levels above which would be obtained from a typical vegetarian diet. OK, so the first way to conserve NAD is to keep oxidative stress to a minimum. The more free radicals attack our DNA, the more our body has to repair the DNA using an enzyme that is an absolute beast in using up NAD. That's yet another place methionine restriction, protein restriction comes in, lowering free radical damage that can drain NAD stores. The other major guzzler of NAD is CD38, an enzyme involved in the inflammatory process. So, by decreasing oxidation and inflammation, we can better maintain our NAD levels. Let me whip out the unabridged 1,200-page version of How Not to Age that has all the original summary sections that had to get yanked from the book to review what can we do to lower oxidative DNA damage and inflammation. OK, let me see. Is this showing up here? That should work. OK. So this is the original summary of the inflammation section, which unfortunately you won't be able to see in the book, but you can see it right here. And so, to help slow this aging pathway, the aging pathway being inflammation on a daily basis, we should try to consider reducing dietary and endogenous exposure to inflammatory AGEs. Oh, that's a whole nother thing. Advanced glycation end products. Boy, we go way down the rabbit hole, but hopefully there's a lot of videos on AGEs on nutritionfacts.org. You can find out what those are and how we can decrease our exposure to them. We can also reduce senescent cell SASP inflammation. And you're like, what are these terms? What does it all mean? Well, that's the senescence chapter. Boy, so we can go through the summary of that chapter too, but again, I don't want to go too far down the rabbit hole, but basically, there are these zombie cells that spew these inflammatory mediators, and there's things we can do to eliminate those zombie cells, and more importantly, prevent them in the first place. Okay. Third thing we can do is boost autophagy to clear out inflammatory cellular debris. And so that's, I have the autophagy chapter. Remember, that's the spermidine and the coffee and the wheat germ and all that stuff. Okay. Number 4, we can avoid pro-inflammatory food components such as saturated fat, endotoxins, New5-GC, and sodium. And you're like, what are endotoxins? What are New5-GC? Again, I have videos on all those. And I talk about those in the chapter. Again, this is not new information. This is just the summary of the chapter. So you want to learn about this stuff, you can get it in the book. Okay, so how do we decrease saturated fat, endotoxins, New5-GC, and sodium? We minimize our intake of meat, dairy, tropical oils like coconut oil, palm kernel oil, palm oil, and decrease our intake of salt. In fact, one lousy breakfast can double our C-reactive protein levels, which is an indicator of systemic inflammation. Within 4 hours, we can double the level of this inflammatory marker, and that's before it's even lunchtime. And then finally, we can go out of our way to eat anti-inflammatory foods. What am I talking about? I'm talking about legumes, beans, split peas, chickpeas, and lentils. Talking about berries. Talking about greens, dark green leafy vegetables. Talking about tomato juice. And of course, tomato juice, tomato paste, we're talking about sodium-free, no salt added. Oats are anti-inflammatory. Flax seeds are anti-inflammatory. Turmeric, ginger, garlic, cinnamon, cocoa powder, dill. And then in terms of beverages, green tea and chamomile teas are both anti-inflammatory. And then fiber is anti-inflammatory. So anything with fiber. So, intact whole grains, legumes, anthocyanins, those are those bright pigments in berries. Doesn't have to be berries. It could be purple sweet potatoes or purple corn or red cabbage. It's probably the cheapest source. So anthocyanins are anti-inflammatory, so we can get those brightly colored foods in our diet. And finally, salicylic acid-rich foods. That's the kind of aspirin type compound, which is found like in willow tree bark, but also found throughout other plants, most concentrated in certain spices like cumin. So I have videos talking about, you can get levels of this compound in your body as if you just took a baby aspirin by just eating a spicy meal with some of these spices, and that has an anti-inflammatory effect as well. Okay. So these are the things we can do to decrease inflammation in our body. What about decreasing oxidation and oxidative DNA damage? Let's move on to that. Okay. Well, to slow this aging pathway, and by aging pathway, I talk about oxidation, we can exercise. Exercise helps decrease free radicals in the body. That's awesome. And so exercise, therefore, not only boosts NAD production, but slows NAD loss. It's a twofer. Finally, we can next, we can restrict methionine intake by choosing plant-based protein sources, and by restricting protein intake down to the recommended intake, which is 0.8 grams per healthy kilogram body weight. Methionine is an amino acid found particularly in animal protein. So even if you keep your protein intake the same, just switch from animal sources to plant sources, you can decrease your methionine intake. What does methionine have to do with oxidation? It actually increases oxidation. So it's pro-oxidant, a pro-oxidant amino acid. We can activate NRF2 defenses. NRF2 is this really kind of like early warning system in the body that's activated, that basically ramps up all our antioxidant activities throughout the body, boosts our enzymes, antioxidant enzymes, all sorts of other wonderful things. And we can do that by eating green and drinking green. Eating green, dark green, so not just dark green leafy vegetables, but specifically cruciferous vegetables, not spinach, but arugula, bok choy, kale, collards. The cruciferous vegetables, broccoli, is probably the most powerful cruciferous vegetables in general, the most powerful NRF2 activator. Probably broccoli sprouts would be the most concentrated form. I'm sprouting some broccoli sprouts right now downstairs. And then green tea can also boost NRF2, and so activate our antioxidant defenses. Okay, and there we are again. Now we're eating berries and other naturally vibrantly colored foods, very high in antioxidants. So they're anti-inflammatory and antioxidant, very cool. Herbs and spices. We talked about how some herbs and spices were anti-inflammatory. Well, there are some that are high in antioxidants as well. Cinnamon, cloves, garlic, ginger, and marjoram, which is kind of an oregano type Italian seasoning, but if you're going to use oregano, might as well use marjoram. Have even more antioxidant activity and tastes delicious. Tastes very similar. Okay, and then finally, avoid added salt, sugar, saturated fat, and cholesterol-rich foods. These are all pro-oxidant. So eat too much salt, you get more free radicals in your body. Eat too much sugar, eat too much saturated fat, which is mostly meat and dairy and junk, and cholesterol-rich foods, which is mostly, egg yolks. All right, so these are some of the ways we can decrease oxidation, and you note that many things that decrease inflammation also decrease oxidation. Okay, while I have this open, why don't I go through and just go through the summary of NAD before taking questions? What was the summary section, in the NAD chapter before it was removed. Let's do it. And here it is. Here's the conclusion box for NAD. Okay, so to review, NAD is an essential cofactor in hundreds of enzymes, including a purported anti-aging enzyme known as sirtuins. It is unclear if NAD levels reliably decline with age, but raising levels boosts the health span and lifespan of a variety of model organisms, meaning like laboratory animals. But whether or not any of these actually translate to humans, and if so, what's the best way to raise levels? These are subjects of very active scientific inquiry. The four main NAD-boosting supplements on the market: nicotinic acid, nicotinamide, nicotinamide riboside, and nicotinamide mononucleotide. Since it appears that NMN and NR just turned into NA or NAM, oh, what alphabet soup we got here. When taken orally, maybe it's simpler to just take NA or NAM directly, but guess what? NAD can boost NAD levels in the blood, but we don't see the increase in sirtuin activity. Not recommended due to the flushing and risk of more serious side effects, such as getting diabetes. NAM fails to prolong the lifespan of mice and may result in methyl depletion, sirtuin suppression, the opposite of what we're doing this for. NR can improve the health and lifespan of mice, but has not been shown to have clinical benefits in humans. This may be due to microbiome or dosing differences between us and rodents, or to sirtuin inhibition by the main degradation product of NR. NMN has been shown to improve rodent health, but not lifespan, and neither safety nor efficacy has been established in human beings. Sufficient safety and efficacy data are likewise lacking for other NAD-related supplements, such as tryptophan, straight NAD, NADH, NMNH, and NRH. Theoretical risks of NAD supplements exist for certain cancers, inflammatory disorders, and infections. And finally, natural approaches to boosting NAD include exercise and reducing oxidation and inflammation. Dun, 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 as I just covered in the last two videos. All right, let me give the our staff a few moments to compile all the questions, and looks like we will have a good at least 30 minutes to go through all questions. So 5 minutes, we will be back, and looking very much forward to it. All right, there we go. Let's get back to the 5 minutes, and then we'll do question time. All right, let's rock and roll here. All right. Okay, let's do some questions. Let's see how many I can buzz through. Okay, first question. Is there a blood test to see if my dietary intake of nicotinamide meets dietary needs? The niacin, so nicotinic acid and nicotinamide can both be used to prevent the deficiency syndrome pellagra. There's no blood test, but there is a urine test. So the blood levels of niacin don't tell you what your status is, but you can measure breakdown products, methylation products of niacin in the urine. But one shouldn't have to do that. Remember, because niacin is found in the animal kingdom, the plant kingdom, and the fungi kingdom. So basically, niacin everywhere. So I mean, very rare. So we don't see a lot of pellagra these days. It's a niacin deficiency. So as long as you're eating a healthy diet, I would not worry about it. Okay, is it safe to quit cold turkey after taking NR for 4 years? Ugh. Well, we don't have data on that, but because you may be suppressing some endogenous production, I would wean off. So I would decrease your dose over a couple weeks. I mean, you've only been on it for 4 years, and so what's the harm of taking it for a few extra weeks? Or at least that's my thinking on it. But again, there's no data either way. What about IV therapy for NAD? Is it safe to say benefits can help with heat exhaustion? Oh man, that's how you make money. Not just selling people pills, but giving people injections. You can charge $100 for that shit. But however, it's not something I looked into. I did not look into IV intravenous NAD therapies, and I stuck to oral supplements just because I think, I mean, that's what people are just bombarded with all the time. And very few people are going to these kind of anti-aging clinics or these fancy medical clinics where they offer these kind of, I mean, I presume they're all scams, but I haven't looked into it, and so I don't, so I unfortunately can't say anything. Next question. Thoughts on NAD? Oh, injection. Again, I only did oral. And so don't know about NAD enemas, NAD injections, NAD infusions. Yeah, so sorry, I can't address that. Could a nicotinamide deficiency in the diet cause glaucoma? How much nicotinamide do people with glaucoma need to take to stop progression, and are there side effects of the dosage needed? Um, we have observational evidence to suggest that people with lower intake of niacin containing foods tend to have higher levels of glaucoma, but that we don't know if it's cause and effect. And we certainly don't have the randomized controlled trials actually proving you can do anything about progression or stopping it or curing it or reversing it or anything with niacin. Next, does high dose niacin improve vision nerves of people diagnosed with glaucoma? Again, we just don't have any cause and effect data. We don't have clinical trials, and so we don't know. Does the data suggest that NAD stimulates or decreases cancer cell growth? Well, I talked about theoretical risks of boosting cancer. This is what we see in some rodents with NAD boosting supplements. NAD is involved. Remember how I said it's involved in hundreds of different enzymes, one of which is like energy production. Cancer cells use a lot of energy. They use a lot of everything, a lot of nutrition in general. It's hard to it's hard to say whether overall the balance, of course, your immune system that is fighting the cancer also uses a lot of NAD. So, it's hard to tell. We simply don't know. Is Life Extension brand NAD, NR, basically Niagen, trustworthy? I talked about Niagen very briefly, and how both the Better Business Bureau and FDA said all sorts of, condemned the producers for misleading claims. So I would not consider them trustworthy. Do I have any comments on the effects of the Stamets stack? Never heard of Stamets, which is evidently psilocybin, which is like magic mushroom psychedelic chemical, lion's mane, type of mushroom, and niacin, which according to research, works orders of magnitude better than niacin alone for neurogeneration. Well, that is not research that I'm familiar with, and so unfortunately I cannot comment. Do you know whether NR works topically? Ooh, for skin wrinkles. I don't know of, the only topical data I saw was on nicotinamide, also known as niacinamide. This person said, I was sent a free bottle, but it's currently functioning as a paperweight. I presume it's not absorbed through the skin, so if you want to put it on, I don't think it's going to hurt you. I read a scientific review that NAM supplementation of 3 grams a day or less was safe. But doses above that were not. What doses used the negative effects covered? Oh, negative effects were for lower than that. But again, these are like, methylation effects, and things. So just because it changes our metabolism of neurotransmitters and hormones doesn't mean it's necessarily not safe, but it does be like, well, wait a second. If it's interfering with our body's metabolism, maybe that's not such a good thing. Is taking 500 milligrams of niacinamide for skin cancer prevention going to decrease sirtuin benefits to any significant amount? That is it worth taking? So no, it's not going to, is it going to decrease sirtuin benefits? Is it worth taking? If this is then coupled with topical niacinamide, does that cause health concerns? So I'm not concerned about any negative effects of topical niacinamide. But in terms of taking niacinamide for skin cancer prevention, I would recommend it, as most dermatologists do, if you're at high risk for skin cancer. What does that mean? You've already had one skin cancer, you're trying to prevent second skin cancer. I would encourage people to take it. I have, I don't know if I have videos yet on it, but definitely in my Preserving Your Skin chapter, I talk about the really remarkable, amazing RCTs proving that oral niacinamide for can prevent skin cancer in high risk adults, and is definitely worth taking, worth considering. Talk to your doctor about it. Yeah, really remarkable. In fact, the fact that there were these massive studies using something that's dirt cheap, off patent, makes nobody money, shows there was just such amazing effects. Even without the profit, there was a lot of research effort put into it. Okay, next question. I had long COVID, EBV return, Epstein-Barr virus, and mold toxicity. You probably didn't have mold toxicity. What you probably had is someone telling you had mold toxicity, somebody who's selling you mold, mold toxicity supplements, or charging you to take out mold from your house. The whole toxic mold thing is almost all scammy garbage. Anyway, do I have videos on that? I think I do. I think I have videos on that. Yeah. Maybe I should do more because it's so common and people are bilked for so much money. It's outrageous. Anyway, but this person says NMN orally, NAD injections in IV have been vital to my healing. It's had a lot of fatigue. Is there a study showing how long you can take this NAD NMN before it has some negative effects? Well, I mean, we don't have data suggests any amount of NMN is safe. And so I am skeptical that it's actually having the benefits that you ascribe to it. I would talk to your doctor about weaning yourself off of it and seeing if the symptoms remain away and without the risk of taking NMN supplements. The boost in NAD occurred in non-trained center individuals, so is it valid to extend findings to all people? The boost in NAD. Oh, well, that particular study was non-trained center individuals, but there isn't a single study anywhere of someone without that weird genetic mutation showing any increase in NAD using any supplement in any human being. So yeah, and now if you're a mouse, it's different, but I don't think you're a mouse. More details on exercise, please. What's the optimum exercise and duration to boost NAD? Oh, great question. How often on a stationary bike, or the same for resistance training? How many times a week? How much weight? Thanks for the great presentation. That's very sweet of you. We don't know. We don't know. I remember for autophagy, this is kind of typical for these kind of exercise studies, 60 minutes of moderate intensity exercise, just like walking, kind of brisk walking, like 4 miles an hour walking, boosted autophagy in muscles, where they, take muscle biopsies before and after. However, 30 minutes did not work. And so the question is, so let's say you had that data and someone asks you, how long do you have to exercise? Well, 60 minutes works, 30 minutes doesn't work. Maybe 59 minutes doesn't work and 31 minutes does, right? That would be completely consistent with all the evidence we have. So it's like somewhere between 30 and 60, it crosses over from not working to working. Okay, where along that? Does 45 work? We have no idea. There's only been 2 studies that looked at it. Okay, there's even fewer studies, right? So basically, the only study we have is showing that there is, and I'd have to look at those particular studies, how much exercise, how much resistance exercise, how much aerobic exercise paused. So that would be like the 60-minute study. Well, this amount worked. Maybe half as much work too, maybe a quarter of much work too, but we don't know because we haven't really been doing it. But when you get the link to all the videos, go back to that second to last video where it talks about exercise and actually look at it. If it's not right on the screen, it'll give you the citation. You can look that up, or when the video's out, you can actually click on the link and download the PDF yourself and see exactly how much they used. And so then that would be at least the at the very least, that much works. Of course, that doesn't mean less wouldn't also work. Next question. I've had Mohs surgery, which is skin cancer surgery. And my dermatologist recommended nicotinamide. Awesome dermatologist. Very nice, right? Why? Because you're high risk of skin cancer. How do we know? You had skin cancer, so you're high risk getting another skin cancer. Okay. Do the downsides you discussed outweigh the decreased risk of recurrent skin cancer? Downside, no. Take it. You want to decrease your risk of skin cancer. It's really remarkable. Okay. Oh, what do I think about Polypodium leucomatous? Leucomatous for skin protection. I have no idea what you're talking about. Let's see what it is. It is evidently some kind of plant. Is it a plant? I've never heard of this. It is a tropical fern. I'm sorry, I've never heard of it. And so maybe it works. Maybe it's useless. Maybe it's toxic. I have no idea. Let me see if anything pops up in PubMed real quick. Wow, there's literally only a single article with that in the title. And yeah, so it's just a review. Yeah, I'm not seeing kind of a meta-analysis or anything that could give me an answer in a few moments. So sorry. But I will go back and see if there's anything juicy, and if there is, I'll do a video about it. Is apigenin a NAD booster? Yes, I talked about it. Why? Because it was, if I remember correctly, it is the CD38 suppressor, right? So it suppresses that inflammatory enzyme. And so it boosts NAD just because you're not using as much of it. And what is the dose? Oh, I may have mentioned it in the video. If not, I definitely mentioned the foods that it was found in. Again, yeah, I'd have to check out that study. If CRP is an effective measure of inflammation and one's level 0.31, is the body low enough in inflammation? Lower the better. Following daily dozen diet, always looking to improve, but cannot do aerobic exercise in the moment due to post-viral fatigue. You know, it's not what you do today, tomorrow, next week, next month, but over the next, few decades. And so hopefully you'll be able to get back into an exercise track. Yeah, so I think the most important inflammatory marker is actually IL-6 and leukin-6 in terms of aging. It's kind of less typically used. For CRP, we want kind of less than 0.3. You're like 0.31, which is a little more than we'd like. I mean, that's it's totally normal between like 0.3 and 1. So you're totally normal. In fact, you're on lower end normal, which is what we want. But oh my God, we'd like it even lower than that. Okay, so read the inflammation chapter, but you're doing great compared to most people. Okay. Does the necessary reduction in protein to reduce oxidative damage also include reduction of plant proteins? Or does plant protein supplementation have a lesser impact on inflammation and oxidative stress? Great question. Okay, so the primary reason that protein restriction decreases oxidative stress in the body is because we're restricting methionine, this pro-oxidant amino acid methionine, which is concentrated in animal proteins. In fact, in the book, yes, in the book, I was thinking maybe it's just in my presentation. It's definitely in my presentation, my How Not to Age presentation, but I think also in the book, where there's a graph where it just says, methionine per calorie. And so the worst is like, I forget, fish, chicken, eggs, and then kind of red meat's less, dairy's less. But for low methionine foods, you really have to move to legumes, and other plant sources. And so even if you kept your protein intake the same, but just switched over to plant protein, you reduce your intake of methionine. I still recommend reducing protein down to recommended levels, even for plant protein as well. But now this is for assuming you're not going in for surgery, you're not sick, you're not, you're not a burn victim, and there's all sorts of things that dramatically increase protein needs, right? So if you're going in for protein, going in for protein, going in for surgery, anytime you have to wound healing, you cut yourself really bad, you're sick, your body just like every antibody that your immune system, spews out billions of these things. Guess what the antibody's made of? Protein. Like it takes a lot of protein to do wound healing, to do any kind of healing. So protein restriction is only when you don't need extra protein. So you want to actually increase your protein intake when you're recovering from illness or injury, surgery, to improve wound healing. I have a whole section on that in the book. But again, that would be plant protein, but then you would go back down to recommend levels for longevity, assuming you are not injured or sick often. Okay, why do so many vegan chefs call for coconut oil when it appears to be so bad oxidatively? Not just oxidatively, it increased LDL cholesterol, primary risk factor for the #1 killer of men and women. So maybe vegan chefs want you to die. Or maybe they like the taste, or I don't know, or maybe they're getting paid off by coconut oil people, maybe they're sponsored by, who knows, but that just seems silly to me. Is there an ideal percentage of plant protein to stay around or under each day? Percentage of plant protein. Ideally, we should, it doesn't matter when your birthdays, holidays, special occasions, but I encourage people to eat 100% plant protein, minimizing animal protein intake. The foundation of the Blue Zone's food guidelines, based on more than 150 dietary surveys for the world's longest living and healthiest people. #1 recommendation, at least 95% plant-based. Diet has to be at least 95% plant-based. So let's have the ideal percentage, greater than 95%. Of course, that still allows, 95% of 2,000 calories, still is like you could have 100 calories, a little, under 100 calories of animal products a day, and still abide by the Blue Zone's food guidelines. So that's like, tablespoon of butter, or container of a little thing of Greek yogurt, or a third of a lamb chop or something, and you still reach the Blue Zone food guidelines. But in general, it should be, animal products should be flavoring. Condiments, not a big center hunk at the center of one's plate. Okay, if one is sensitive to caffeine, is decaf, green tea, and coffee still beneficial? Absolutely. Check out my video, How Not to Age. Check out my book, How Not to Age. I talk about how the benefits of coffee and a green tea have nothing to do with the caffeine. In terms of autophagy boosting, it's the antioxidant in coffee, chlorogenic acid. I talk about the ways to get higher and higher chlorogenic acid levels, which brands to pick, etc., how to brew it. And then green tea has this really cool hormesis effect, again, nothing to do with the caffeine. So yeah, decaf coffee, same life extension benefit. 13 to 17% lower all-cause mortality. Drink 3 cups of decaf coffee, similar to what you see with 3 cups of regular coffee. And you don't get like the jitters and interfering sleep and all those other things. Okay. Whew, we are lightning rounding this puppy. What was the grain? Oh, what was the grain you like to add to your grain bowl that is sometimes hard to get, but it's good to increase NAD? Well, red sorghum. In fact, I just discovered black sorghum. I think I did a video talking about how, oh my God, black sorghum has even more antioxidant content than red sorghum. I think that's what it's found. I have a sorghum video talking about the benefits of colored sorghum grains, but I was like, I can't find it anywhere. Well, guess what? Someone sent me a red sorghum that they made, like some farmer who's gonna commercialize it. I don't know if that's actually happened yet, but I was just at the Vancouver Planted Expo, and there was a guy selling black sorghum. I believe the brand name was Smilo. I don't remember that because it's such a weird name, Smilo. And he gave me a jug of it, like a milk gallon of black sorghum. Unfortunately, it was so heavy, it was not worth shipping back. It's very expensive to ship stuff from Canada back to the States. And I just could not drag this this thing around in my carry-on. So I unfortunately left my black sorghum in Vancouver, and so I'm out of black sorghum. But boy, would I love to have that for my Brol Bowl, which stands for barley groats, lentils, particularly black lentils, beluga lentils, oat groats, and lentils. Wait a second, what's the R? Rye groats. Sorry, R for rye, not for lentil. Okay, next up, how severe and how often should protein restriction to promote autophagy? Protein restriction is the only thing I can find that boosts all 11 of the anti-aging pathways. So autophagy is one of the 11, but it works for every single one. The only thing it does, even smoking cessation works for less, or avoiding, animal products or junk food or all the other things we can do, exercise. Okay, so protein restriction, 0.8 grams per healthy kilogram body weight. What does that mean per day? So that's about 45 grams a day for the average height woman, 55 a day for the average height man. You can convert that into pounds. I believe that's 0.36 grams per pound of healthy body weight, meaning your ideal body weight in pounds times 0.36 should give you the equivalent. And then over age 65, you can increase that to 1 gram per healthy kilogram of body weight, which I believe is 0.45 grams per healthy pound of body weight. Okay. Is there any relationship between NAD levels or activity and motor neuron disease such as ALS? Well, I would not be surprised since NAD is involved in basically everything in the body. But the question is, can you actually do anything about it? And I haven't seen anything in regards to specific NAD boosting in ALS, but I am doing an ALS treatment video. A close friend of the family was diagnosed with ALS recently, a particularly rapidly progressing form of ALS. And so I put on my little research cap and did a deep dive in everything that could possibly help. And I actually found some really interesting data involving B12 injections. I mean, absolutely massive doses. In fact, I actually got some B12 and injected her with it. Boy, is that cool stuff. It's like ruby red. I felt like a mad scientist. I forget the dose, but it was like some ridiculous dose of B12 versus placebo actually shown, and these are injections, shown to slow progression of ALS. I forget, I think there's 3 studies now. They all showed a promise. Of course, you don't hear about it because no one's making any money off of it. But I was like, why doesn't anybody know this? It's like this horrible disease, and there's something we can do about it. And so I will be doing an ALS video and talk about all the other things I found, but that was the one that struck me with enough evidence to actually put it into practice. Okay, any help for this? The question is, any help for peripheral neuropathy? It depends on what kind of peripheral neuropathy we're causing. So peripheral neuropathy just means like, a disease of the nerves outside of the spinal column or the brain. So like peripheral nerves, like numbness and tingling in your fingers or something like that. And it can be caused by a whole bunch of things. B12 deficiency can do it. Diabetic neuropathy is a very common cause. High sugar levels can be toxic to the nerves, and so you can start killing them off. That's why your feet can turn numb, and then you can suffer injuries to your feet and get diabetic foot ulcers and all sorts of terrible things. So as with everything, treat the cause. Find out what the cause of your peripheral neuropathy is, and then treat it. Oh, another thing that can cause peripheral neuropathy is actually selenium toxicity. Remember I had that video saying, eat 4 Brazil nuts once a month and decreases LDL cholesterol. This is too good to be true study. But I warn people, look, don't eat more. That you don't want to eat 4 a day. That's way too much selenium. In fact, even 1 a day may be too much, actually increases inflammation. But this person didn't see that and was just eating massive. It was like, oh, if a few Brazil nuts are good, maybe more is even better. It's home Brazil nuts. They started losing feeling in their feet or tingling in their feet, something. And I think they may have had selenium toxicity. So I said, stop eating Brazil nuts. Did not you see? That's the whole second half of the video. Don't eat too many Brazil nuts. So anyway, moral of the story, watch the entire Nutrition Facts video, not just the beginning part, because I may be like, yeah, but it kills you or something like that at the end. So watch the whole thing, or at least read the transcript, something. Anyway, whew. Okay. Does intermittent fasting have any effect on reducing oxidative stress and inflammation? It depends when you do it. Early time restricted feeding will do it. But if you have a late eating window, like you skip breakfast, only eat supper, you can actually cause yourself harm. Yeah, okay. Otherwise, I have lots of, I have a whole video on caloric restriction that goes into the various types of fasting and what it can do in terms of longevity and health span. Next question is, it looks like we're kind of off topic, but that's fine. I'm a vegetarian. I don't take extra B12 supplements, but my lab work always says high B12. Is that concerning? I'm a vegetarian. Don't take extra B12 supplements. So you take some B12 supplements? Maybe it's in a multivitamin. Maybe you're eating nutritional yeast or other things that are fortified with B12. Otherwise, I'm surprised your HDL's high. Whether that is concerning, that is a topic of it's on my video topics list. I do have a video dismissing most of the early data, but we have new data now, and we'll find out. Next question. I have low HDL, but normal total cholesterol and LDL. What can I do to increase HDL? Well, if you have normal cholesterol and LDL, then that's bad because it's normal to die of a heart attack in this country. Number one killer of men and women. You don't want normal LDL and total cholesterol. You want ideal, which is for primary prevention, meaning you don't have heart disease, less than 70 for HDL, less than 150 for total cholesterol. And if you have heart disease, and even way lower than that. And we don't worry about HDL. Why? Because it's not a causal risk factor. We used to think HDL actually made a difference, but it's not a causal risk factor, and I have a video on that if you want to know how the science has changed. Okay, what can I eat to fight skin fungus? Besides exercise to boost blood flow to my skin, how can I fight skin fungus topically? I've got a whole video. Well, I have toenail fungus. Oh no, but I talk about, and I have video. Okay, so I have a section on toenail fungus and how not to age. Then I have a bunch of videos on both scalp fungus, that can cause dandruff, and then athlete's foot fungus on the feet and what we can do about it. I think it was like a tea tree oil video, something like that. I forget if tea tree oil actually worked. That's why I do videos, to find all that stuff out. And then I forget about it. But why keep it in my brain when there's a video on nutrition facts I can always refer back to? That's funny. I go to my own videos to find out what the conclusions are, because I've got there's thousands of videos now. I think we're at over 2,000 videos on nutritionfacts.org. All right. I am skeptical about the quality of supplements, yet I recommend vitamin D3. Is there a type or brand we can trust? I recommend getting USP certified brands. That's an independent testing company that does not tell you if the supplement is good for you or not. It just tells you that what's on the label is what's in the pill. Maybe what's on the label is like way too much, and they still have a USP certificate of approval on the bottle. Again, they're not saying if it's a good dose, a bad dose, a good supplement, a bad supplement. They're just saying they've tested it, and it's what's on the label is what's in the pill, within a small, error range. And like, isn't that ridiculous that you'd actually need to do? That's just because the supplement industry is so Wild West. They can sell stuff that is absolutely none of the active ingredient, or even worse, has added drugs, or even illegal drugs, all sorts of terrible stuff. Anyway, so USP has this, is a kind of a trusted certifier. And so there's a lot of common, I think a lot of the Kirkland brand, like just like a Costco brand supplements, they actually pay extra to get that USP certification, but it's worth it so you know what you're actually taking. All right, we are closing down now. I have some exciting news in terms of the last, maybe the last webinar of the year, but definitely another webinar. More CME webinars coming up, and guess what? The next one is on Ozempic. It's been way too long. I've been just to weigh in on the Ozempic thing, the pros, the cons, who should take it, who should not take it. Are there natural ways to to resemble mimic Ozembic's effects without the price tag, without the risks, and all that stuff. Oh my God, it's gonna be juicy. And so I believe it's gonna be September 27th. And he's like, wait a second, it's like 2 months from now. Well, I got to do the research first. It's gonna take me a while, but that's what I'm actually going to be doing on my plane flight to the UK next week on my finals How Not to Age speaking tour date. And then I got a plane ride back. It's like 7-hour flight. I'm gonna have lots of time to start the Ozempic research, and time for videos to be made, blah, blah, blah. It takes a long time to have this stuff happen, but it will happen. And so mark your calendar, September 27th, I think. And make sure you're subscribed to the Nutrition Facts newsletter, for free, of course, for the details. Thank you so much for joining me. I hope this was education. Bye, everybody.